This short video here will provide us a quick review for what we have learned: confidence interval, margin of error. Try to provide a very quick chapter review for all the stuff we have learned. So hopefully at the end of the video, you can have a feeling that, come on dude, it's not that hard. Recall what we have learned for the confidence interval. We have the middle, which is usually coming from the sample average. We are using the notation X bar, right? And then since we are talking about confidence interval, there's a lower limit, there's an upper limit. So how do we get the lower limit? We have to use the sample average X bar minus something. That something, we call that margin of error. Similarly, we have the sample average plus something, which is the plus margin of error to get the upper limit. Based on different situations, we have to apply different formula. If you remember, if we are given sigma, which is the population standard deviation, we have to use the formula. So we are using the X bar, right, the sample average, minus plus what we call this box here is the margin of error to get the lower limit and upper limit. Now, if it's sigma is not a given, then you have to give me something else. For example, if you are giving me the sample standard deviation S, then we can use t distribution, t formula. Remember, alphabetically, S and T, they are next to each other. They should be connected, right? Whenever we are given S, we have to use t formula. Now, this t formula here help us give now the margin of error formula will be that one. In other words, margin of error will also be changed based on different situation. Similarly, if we are not given anything about standard deviation, right? We don't know about sigma, we don't know about S, the sample standard deviation. You have to give me something else. Then this situation here, we should be given in terms of the proportion from some samples. Usually they are given some number out of how many total samples, right? So you have this p hat, 1 minus p hat, which is a q hat. So we are using this new confidence interval, and the box formula here is this new margin of error formula to do the calculation. So hopefully this provides you some quick review for what we have learned: confidence interval and also margin of error. Now let's do some tricky homework, tricky questions. Either you are studying the exam for statistics or even for AP statistics, right? This question come up a lot. They ask you how large the sample is required, right? So this question here, a recent poll of 700 people who work indoors found out 278 smoke. So based on that sentence, we know there's a proportion we can calculate here, right? So usually it's the p hat. Hat usually refers to some estimation, and most of the time referring to sample estimation. Next time, whenever you see hat, that reminds you this must coming from some sample estimation. So p hat usually something out of something. Most of the time you see x out of n. So 278 out of 700, that give us 0.3971. One popular question, professor, how many decimals we should keep? Right? If you remember the z-chart, usually the proportion, the probability in the middle is like at least 4 decimals. So in other words, we should keep at least 4 decimals, or to be safe, you can keep 5 decimals. You can round to 5 decimals. Similarly, q hat is 1 minus p hat, right? Which is 0.6029. So now based on that sentence, right, we translate into mathematical formula, what is p hat, what is q hat. Continue if the researchers want to be 98% confidence of their results to within 3.5 percentage points. That is a very confusing question. We have to be very careful here, right? How do we understand these 3.5 percentage points, right? So if you remember previously in our confidence interval, right, you have the sample average in the middle, right? Usually we talk about 95% of confidence. So in this case here, we are talking about 98% of confidence. So in other words, we have to minus something, we have to plus something. But in the question here, they want to see when we plus or minus, at the most is 3.5%. So in other words, the margin of error here is 3.5%. So that's the information we are given based on this here, right? Now we check where is this 3.5% should be. Based on these three scenarios here, we are not given sigma, we are not given S. We only give something about the proportion from the sample, p hat. So we have used this boxed formula here, which is the margin of error formula in this situation here. So I can write down this portion is equal to 3.5%, and I have to write down this as a decimal points, right? 0.035. Everyone, be very careful here, right? Now, after we write down that, we have to ask ourselves, what is the question, right? How large a sample is necessary? Everyone, the first question I got, or we can ask ourselves here, what is exactly asking here? Why we ask a sample again? Because we already have a sample, a recent pool of 700 people. It is one sample already. Why you are asking another sample? So that means most likely this 700 people is not enough to give us this 3.5%. If it's enough, then the answer, we shouldn't ask this question, right? We shouldn't be that dumb. So in other words, if you check the answer A, B, C, D here, right, the sample most likely should be some number bigger than 700. So in other words, the answer cannot be A, right? We can easily cross out answer A. We can easily cross out the answer C. So most likely the answer will be either B or D. So that's very quickly to give you some idea in terms of, because these are multiple choice questions. Now, we can plug in what we have from this formula here, everyone, right? The first part, you want to figure out what is this Z alpha divided by 2. So in other words, this is just some number in terms of Z, right? How do we find out Z? We have to use the Z chart. So this question here is kind of tricky. Why? Because we are doing backward, right? When we're talking about backward here, 98% in the middle. If you remember, right? 98% in the middle, right? So in the confidence interval, that gives us each side here is about tail, is about 1%, 1%. If you remember the bell-shaped curve, right? So that gives us, based on that 1%, which is 0.01. Then we check on this Z chart here, right? 0.01. Everyone, be very careful. We are looking for probability, right? So which number here is more close to 0.01? This one here, highlight here, is the most close one, right? 102 is kind of a close, but this one is more close. Corresponding number here, negative 2.33. Remember, in the formula, Z is always taken positive, right? Otherwise, we plug in someone here that is negative. How come we can get a positive number, 3.5%? No way, right? So that help you. We should plug in 2.33, right? Multiply square root of, right? What's P hat? We already calculate that here, right? What's Q hat? We already have that here, right? Divided by square root of n. Everyone, be very careful, bracket here, right? At the end is equal to 3.5%, and we put them in a decimal format, right? Now is back to our algebra teacher, right? How do we calculate the sample size n here? right? To get that, we have to put everything, right? So that should give us 0.035 divided by this portion here, 2.33. That give us a square root, right? And then we have to get rid of the square root. We have to square both sides, right? So we have this formula here. And then how do we calculate the n here, right? Something divided by n is equal to this part square. The n is equal to this part here divided by this portion here. Everyone, if you plug the whole thing here into the formula, right, you will get this number. So I will ask you try to avoid take the square of that here in the middle. Why? Because you have to get a consideration how many decimals to keep, right? Usually you don't have to consider that. You just plug everything if possible, right? Plug everything here, then you will get an answer very close, right? 1061.2 samples. That's many people, right? Now back to our question. That's our sample size. How large a sample is necessary, right? Minimum of 1061.2 people, right? We cannot have a 0.2%, which will be very scary, right? So at least 1062 people. The answer should be B. So hopefully that give you a clear understanding. How do we solve this kind of sample size question? How do we solve confidence interval margin of error? Come on, dude. It's not that hard.